Hello, I'm Lois Letchford, author of the book Reverse to Memoir, founder of Teaching Students with Dyslexia and a Literacy Problem Solver, sharing the works and the readings of Isaac Newton, a man who changed the world. And this one is part 2, and it's called Fired by Genius, College Days. Since the Middle Ages, the buildings of Cambridge University had risen to the Cam River about 60 miles south of Isaac Newton's home. One of the university's best colleges was Trinity, which had been founded by Henry VIII in 1546. It was at this great institution that Isaac was enrolled on June 5th, 1661. Cambridge University had gone through difficult times during the Civil War. Royalists had lost their job. Now King Charles II, Charles I's son, was on the throne, and it was the Puritans who had to be careful about what they said or wrote. Young Isaac was something of a Puritan at heart. Although he occasionally went to the taverns, he never got into drunken fights with some of the other students. He was full of religious anxieties and slow to make friends. Students were classed into various groups. At the top were the privileged nobles. Then there were the ordinary students or pensioners. The lowest class of students were the subsidiaries, who had to act as servants to other students in order to pay for their studies. Isaac was in this lowest group because his mother did not want to pay his fees. Isaac was expected to start his studies in the traditional way by studying ancient Greek philosophers such as Aristotle. He worked hard, but it was not until his 3rd year that he really came into his own. He began to read other ancient philosophers and also contemporary thinkers such as Galileo Galilei. Isaac applied his mind to great questions of science and tried to find answers. He set up experiments in his room using contemporary scientific methods of observation and measurement. He took up mathematics, filling notebooks and figures and diagrams. In April 1664, Isaac was appointed a scholar, which meant he received a scholarship. In January 1665, he received his bachelor's degree, graduating in April of that year. With this scholarship, he could now afford to stay at Cambridge and continue his research. It's then the borders of knowledge, and at the time we're looking at Galileo Galilei, Tycho Brahe, a Danish astronomer, and René Descartes. Descartes tried to work out the structure of the universe itself. He believed that matter filled all space and formed whirling patterns called vortexes. Newton was fascinated by these ideas and the mathematics of Descartes, but soon found fault with his theories. The Crucible. The crucible is a dish used to heat metals or other substances to high temperatures so that precious materials can be gathered. For Isaac, the years 1665 to 1667 were a crucible. Unable to continue working at Cambridge, he went back to Woolsthorpe, where his genius was unleashed. The precious material that resulted was a new understanding of our world. These years in Newton's life were sometimes known in Latin as Anni Milleribus, meaning marvellous years. However, they occurred at the same time of 2 national disasters. In June 1665, the bubonic plague broke out in London. It was a terrible, deadly disease which was spread by rat fleas, although no one knew that yet. As the plague spread out onto the countryside, there was panic. Cambridge University was closed. By October, 70,000 people had died in the capital alone. Isaac had nowhere to go but home. He rode north to Woolsthorpe Manor that August and remained there until March 1666. But when he returned briefly to Cambridge before taking refuge in Woolsthorpe again until April 1667. I think we can relate with the pandemic that we had. It's very similar to what would happen with the bubonic plague back in those days, 400 years ago. Freed from examinations and the irritation company of other students, Isaac was able to think creatively and to experiment. He made brilliant advances in mathematics and the science of physics. On September 2nd, 1666, a second disaster struck London. The Great Fire broke out in the city. Londoners took to the boats and the River Thames to escape the heat. By the time the fire had burned out 4 days later, it had destroyed 13,000 homes, 89 churches, and St Paul's Cathedral. About 100,000 people were made homeless, and an unknown number were killed. Much of the old medieval city lay in ruins. It was time to build a new city. As a natural philosopher, Isaac Newton tried to understand more about the universe. His aim was the case with many other scientists of that age was a religious one. He wanted to shed light on the wonders of God. However, the more he followed the demands of science, the more his belief drifted from the traditional teachings of the church. Mathematics was Newton's greatest love. It was not some abstract notion to him, but a practical tool that could explain how things worked or why things happened. In February 1665, Isaac had developed a binomial theorem. This was a clever use of algebra to work out logarithms with a greater degree of accuracy. Logarithms were tables of figures that made it easier to do very complicated sums. Logarithm tables were very useful in the days before electronic calculators. 3 months later, Newton was studying orbits, the paths taken by planets as they circled the sun. He tried to find a way of describing their course in mathematical terms. He decided this could be done by considering the curved path in terms of a series of tangents. In geometry, a tangent is the point at which a straight line touches a curve. Isaac was fascinated by the way in which a straight line might be broken down into a series of tinier and tinier lines and eventually becoming a curve. Starting in November 65, he spent 3 years working out a system for calculating ever smaller measurements. He called it fluxions, but we know it as calculus. This combines arithmetic with geometry and algebra to compare the rate of change in one thing to the rate of change in another. For example, it can compare distance travelled with time taken to show changes in speed. Calculus can be used to work out the length of a curved line or the area of irregular shapes. New science. The branch of science that we call physics was at the heart of Isaac Newton's inquiries as a young man. Isaac was fascinated by what he decided must be the tiniest particles of matter, called atoms. He also carried out a series of experiments to discover the nature of light itself. Isaac Newton knew the ideas of atomism in the Cambridge philosopher Henry Moore, who had been born in Grantham. He also read the atomic theory of the French scientist Pierre Gassendi. Isaac decided that atoms must exist as the smallest invisible particles of matter, so tiny they could not be seen. It was not until 1897 that the English physicist J.J. Thomson discovered that atoms contained even smaller particles, which he called electrons. Later, scientists discovered that atoms also contained other particles, including protons and neutrons. But what was light? We know now that it is energy that travels in waves. Newton believed it was made up of particles. In fact, the modern theory of physics was called quantum theory. Shows that he was partly correct. René Descartes believed light was some kind of pressure, that colours were a mixture of light and darkness. Newton was not convinced. He tried some very dangerous experiments. He poked bodkin, a kind of blunt needle, behind his eye to see what would happen and describe the colours that he saw. He also tried staring at the sun as it appeared reflected in a mirror. He was lucky not to be blinded and afterward had to spend 3 days in a darkened room. A less dangerous experiment was carried out using a prism, a triangle of glass that had brought at Stalford Fair near Cambridge. When the sun shone through it, the prism gave off a range of colours. Isaac realised that white light was actually made up of all these different colours. When light was bent or refracted by the prism, the separate colours became invisible. The same effect is created as a rainbow when the sunlight is scattered through the natural prism of a raindrop. Isaac's discovery was a very important breakthrough in understanding light. One late summer day, Isaac Newton was sitting in the orchard of Woolsthorpe Manor when an apple falling from a branch startled him. It set him thinking about gravity, the force that pulls objects toward Earth. At least, that is how the story was told many years later. The legendary apple became one of the most famous fruits in history. Isaac must have considered the question of gravity before. He had studied the work of Galileo and Kepler about gravity. But perhaps the fall of the apple really did set him thinking again. Gravity would occupy his mind for the next 20 years while he worked on and perfected his theories. If the Earth's gravity pulled the apple downward, why was the moon not pulled down to Earth as well? Newton took a step back from the problem and asked himself another question. Why did the moon not fly away into space? Perhaps it was held in an orbit around the Earth by the force of gravity. This was the first time that anyone had wondered if gravity might govern the planets as well as objects on the Earth. Like a ball attached to a string and whirled around one's head, the moon could not escape. The reason it could not crash downward like an apple was that, at a distance, the forces of gravity was weaker than it was at the Earth's surface. In April 1667, it was time for Isaac to leave Woolsthorpe. Cambridge University was at last returning to business after the plague years. Isaac's mother gave him some money, and he headed south to the university once again. Isaac's months of refuge in the countryside had been well spent, although few people had heard of the young Cambridge scholar. He was already the leading scientist or natural philosopher of his day. Thank you. Enjoy, hit like, hit subscribe, and start asking questions, just like Isaac Newton did all those years ago.